Hello everyone, welcome to the video lecture on probability and random variable. I am Professor Mayur Gohil. In this video lecture I take up the following question to find the MGF of the random variable x, and hence we have to find the first four raw moments. So now let us see how to calculate this kind of a question, because this can be little tricky for some students, because when it is said to find MGF and hence find, so first MGF is to be found, and using MGF we have to find the first four raw moments. So how do we solve this? So we be very careful while solving such a kind of question. So first thing, we make the table in the vertical format. Okay, having made the table, we now write the theoretical thing, and then we will extend some columns ahead. Now let us see what all things we have to write. So MGF is mxt expectation of e to the power tx. Okay, this is the format, this is the main definition of MGF. Therefore mxt in our case, because x is a discrete random variable, we will have summation e to the power tx times probability of x equal to x. Now we need one column here, e to the power tx. So that let us draw that, make that column e to the power t x. So what we do is e to the power t into 0, so that is going to be 1 here. Okay, e to the power t into 0, so that is going to be 1 here. The next is e to the power t, the next is e raised to 2t, then here it will be e raised to 3t. This is the column that we get. Okay, now the next column is we multiply e raised to tx and the probability p of x that we have got. Okay, so here it is going to be 1 over 8. Here it is e raised to t into 3 by 8. The next is e raised to 2t into 3 by 8, and the last one is e raised to 3t into 1 by 8. Okay, so addition of all these thing is my total. So let us add them up. So therefore mxt, I'll not add it over here because it becomes very congested for writing. So mxt is addition of all these values that we got. So 1 upon 8 plus e raised to t times 3 upon 8 plus e raised to 2t times 3 upon 8 plus e raised to 3t divided by 8. Okay, so this is our MGF. Now to find the first four raw moments, so let us see how to do. So this is the MGF. So to find raw moments, we first take the derivative of the mxt. So therefore mu r dash is equal to the rth derivative with respect to t of mxt, evaluating this at t equal to 0. So this is what we need now. So let us see what will happen. So we first calculate the derivative. So first derivative of mxt is e raised to t into 3 by 8 plus 6 e raised to 2t by 8 plus 3 e raised to 3t by 8. Okay, so this is what you get. Now this derivative evaluated at 0 will give us mu 1 dash. Okay, so because this is the first derivative, therefore mu 1 dash is equals to the d by dt of mxt t evaluated at 0. So what will happen here? It is going to be 3 by 8 plus 6 by 8 plus 3 by 8. So basically it is going to give us 12 by 8. 12 by 8 answer is, so it is 12 by 8, which is going to be 3 by 2. This is our mu1 dash. Okay, so that's what we get. Now let us calculate the next derivative. Now mu2 dash, mu2 dash is basically the double derivative of mxt with respect to t, which is evaluated at t equal to 0, right? So we now calculate the double derivative. So d square by dt square of mxt. So we calculate this derivative. So we had already calculated the first derivative. Okay, we again do the derivative on that itself. So what we will get is, so for the first part will be 3 by 8 e raised to t, no change there. The next part, it will become 12 into e to the power 2t divided by 8. The next part will become 9 into e raised to 3t divided by 8. Now this is what is to be evaluated at 0. So therefore mu2 dash is going to be 3 upon 8 e to the power 0 plus 12 in upon 8 into e raised to 0 plus 9 upon 8 into e raised to 0. So what we get is 15 plus 9 is 24 upon 8, which is 3. So mu2 dash is 3. We have got the answer for mu2 dash. Now we calculate mu3 dash there. Now mu3 dash is basically the third derivative of mxt evaluated at t equal to 0. So we calculate, we do the derivative once more on the second derivative that we have calculated. So we get here the third derivative of mxt is 3 e raised to t over 8 plus 24 e raised to 2t divided by 8 plus 27 e raised to 3t divided by 8. Now this derivative, when evaluated at 0, we get mu3 dash is equals to 3 over 8 plus 24 over 8 plus 27 over 8. So it is going to be 27 by 4 is the answer. Okay, so that's what it is going to give us. Now we calculate for mu4. So now mu4 dash is the fourth derivative of mxt evaluated at t equal to 0. So therefore the fourth derivative over here is basically, the fourth derivative is basically over here. We take the third derivative, which we had already done the derivative. We use that and do the derivative over it. So it is going to be 3 e to the power t over 8 plus 48 e raised to 2t divided by 8 plus, it will become 81 e raised to 3t divided by 8. Now this, when evaluated at 0, mu4 dash will give me 3 over 8 plus 48 over 8 plus 81 over 8. So this is going to be 51 plus 81 divided by 8, so that is basically 132 divided by 8. 33 upon 2 is the answer. So this is how we calculate the first 4 raw moments from the MGF. I hope you have followed the procedure. So this is our mu2 dash, this is mu4 dash, mu3 dash is here, and we had our mu1 dash over here. Okay, so and this is our MGF. So I hope you have followed the procedure. So the procedure is that whatever MGF whatever uh, PMF is given to us, you first calculate the table properly. So make the table of e to the power tx and e to the power tx into p of x. You get the values properly. Once you get those uh, values, you add them up, you add it up over here, and you go on taking derivative. Each time you evaluate at 0. Need not do simplification too much, you just because the coefficients are important over here. E to the power t terms are all going to vanish and become 1. Rather, they vanish, I mean they will become 1. So it will assist us. You need not do the all simplification, because the moment you put t equal to 0, e to the power t terms are going to become 1. So you need not do too much of simplification. You can keep the coefficient as it is and they will assist you further. So here you have this way of calculation. Okay, so I hope you have followed the procedure and understood the example. Till then, keep solving good amount of mathematics. Please hit like button and subscribe to my channel. I shall soon see you in other video lectures. Thank you.